Welcome back to the course. My name is Derek Colley. Today we'll be talking about handling digital evidence with reference to the ACPO guidelines. This video is short and mostly theoretical in nature. We will be talking about some of the core concepts that we need to bear in mind when we are handling digital information on a target system to make sure that we preserve the authenticity and integrity of that information. We will refer briefly to the ACPO, the Association of Chief Police Officers Guidance, last issued in 2012 for the handling of digital evidence. There are some updated guidelines, but sadly they're hidden behind membership of the Policing College for the UK. So the 2012 guidelines are a fair summary of some of the key points I want to talk about, and you may wish to consult your local jurisdiction's guidance on these matters for similar guidelines. So without further ado, there's a link here on the slide to the Digital Evidence 2012, and you may want to refer to your local regulatory framework, but I've pulled out some of the key points and we'll take a look at the document itself as well. So when we're considering digital forensics, we've got three key stages to go through. We need to acquire the material that we want to analyze. We need to analyze that material and create a report. And the output of the reporting stage is some evidence that can be submitted for further use by a court. So let's define each of these terms. Acquisition. Now, you may think that we can simply take control of a target PC and start pressing buttons and working with that. That is not typically a good idea for several reasons. The first is that by interacting with your target device, you may inadvertently change data or undermine the integrity of the data on that system. And that can be used to essentially undermine the validity of the work you've done and cause your evidence to be inadmissible. So what we prefer to do, what the guidelines state, and what is generally good practice is first test the proportionality of what you want to do. Computer systems can be huge these days, multi-gigabyte, multi-terabyte systems. Do we want to necessarily copy everything and have to wade through terabytes of information? We may want to do selective dumps of information. So the first thing is to make a plan for what information you want to target. The second is to acquire that using the most minimal approach to disruption possible. So, for example, dumping live memory should be done through a single pass read-only operation out to a target device, such as using a dump file off disk. You may want to image the whole of the storage media, or you may want to image part of it or take individual files. Typically speaking, we prefer to do block level, disk level copies of information rather than logical copies, because the logical copy that you take may have different metadata within it to the original, which means that you can't conclusively prove that it's a copy of the original file that you originally analyzed, which can be problematic when it comes to authenticating your evidence. But by and large, and we'll do a demonstration of both of these in the next video, we want to take a copy of the live RAM and we want to take a copy of the media that we're interested in. And bringing this down to database forensics, that means typically we're interested in the state of the RAM for the processes that are managing our database servers. And again, in the demo, we'll show how to create dump files of those specific processes. And we're interested in the files or the drives, let's say, which may contain database files. And again, in the demonstration, we'll do a brief demo using DD, using Windows Subsystem for Linux, which is a really handy way of dumping copies of files to another drive in a way that doesn't surrender the integrity of those files. Then once we actually have the data on our separate system, we're safe, we can breathe a sigh of relief, and we can start the process of analysis of that data. And then when we do that, we'll talk briefly today about contemporaneous notes and journaling, the importance of maintaining an audit trail, and essentially a digital chain of custody for that. And then in reporting, we want to assemble our findings and present them in an accessible format. Towards the end of the course, we'll talk about that in a little bit more detail. But essentially, it's the techniques you'll learn during the course of these sections will give you those skills to be able to assemble what you've found into a meaningful format. So there's two guiding principles of digital forensics. One is integrity and the second is authenticity. So for integrity, we want to ensure that investigation of digital evidence doesn't alter the original data insofar as possible. such as the evidence we gather is a reflection of the original evidence and is reliable. And secondly, authenticity. We want to ensure that we can guarantee the evidence we gather is authentic. So we want to, for example, compare imaged or copied evidence to the original to show that the sets of data are identical. So what do these two terms mean? The first means that we need to make sure that what we're gathering is true and accurate. If you can imagine opening a Word file, for example, having a read through and closing that Word file, saving and closing that Word file, you've actually altered that Word file in the process of reading it by when you've saved and closed, or even by closing without saving, you'll alter the metadata in the header of that file to say last accessed on such a date. And because you've altered that metadata of the file, a reasonably good defense professional might say, "Well, hold on, you're presenting this file as my client's own work, and this file is not in fact my client's own work, because you can see when we compare the two files side by side in the contents, they differ." Okay, therefore, there's a question mark over whether this document was altered post collection, which means that it might be inadmissible. And that general principle extends across many different types of files and many different techniques. So ideally, we need to make sure our investigation takes true copies of everything, and that we can evidence that in some way. And then authenticity, we need to ensure we can guarantee the evidence we gather is actually authentic. So that's the process of comparing what we've gathered to the original files that we've gathered. And we can do that through techniques like hashing, or we could perhaps aggregate records from an original and compare them to aggregated records from a copy and show that the two sets are identical. And we'll do some of that as the course progresses too. So some audit considerations. When you're conducting a digital forensics investigation, and this is true of database forensic investigations, consider an imaginary adversary who is criticizing what you're doing by standing over your shoulder. So they may challenge your collection of the evidence on a number of bases. They may say that there is little audit or documentary trail of your evidence collection, that your methods might have changed your data knowingly or unknowingly. Okay, so for example, they might say, well, actually, you copied that file from A to B, and the file got corrupted, so therefore it's not admissible. Or maybe you opened that file, looked at it, saved it, and then copied it, and that means it's not an original of my client's computer system. Those minefields are quite difficult to avoid. We have some tooling in the industry, such as EnCase, which will help you establish a contemporaneous audit trail for anything you do around analyzing a system using typical digital forensic techniques. There isn't a tool to do this for databases specifically. Okay, so tools like EnCase might be useful for you to work with as a framework, but database forensics is quite an understudied and niche field. So what can we do to avoid these kind of accusations? Well, there's some technical answers and some non-technical answers. So for database forensics, these tools don't yet exist. So always image or copy data, verifying its authenticity to the original where you can, and work on the copy. And consider using video and screen capture tooling. So maybe work with a partner or work as part of a team and get that person to take notes. Use live video stream when you're analyzing the copied data. Use screen captures and screenshots where you can. And use something called contemporaneous notes, which is where you are taking notes as you go. This could be pen and paper or in a tool like EnCase to establish what you did and when and why. And those notes can be admissible. So the basic approach to imaging or taking a copy of the system, what can we do? Now, this varies according to operating system. I'm going to assume for the most part we're using Windows, but I'm going to use a couple of crossover type techniques such as DD, which is a tool for copying files in whole on a mostly Linux system, but it can be adapted for Windows subsystem for Linux, which is what we're going to show you. So we're going to do that that's for storage media capture. And because we don't want to copy the file and move it somewhere else as such, we want to take a copy of the underlying representation of the file and move it somewhere else. And that's something a little bit different. The physical copy, not a logical copy. We want to take that block level copy. We, in our demo, use the example of using DD to take a copy of a whole file system, so my local C drive on my Windows machine, to a USB drive. Okay. And we'll start that process off, and obviously we won't finish it because it will take several hours, but we can show you a very simple way of doing that. And then the second thing we can do is live RAM capture. So When we first arrive behind the keyboard of a machine that we have to analyze for evidence, before we open any files or take any kind of storage media captures or anything like that, it's good practice to capture the state of the RAM for the applications that we're interested in. So for a traditional digital forensic examiner, that might be the whole of the RAM on the Windows machine that we're working on, or Linux machine we're working on. It might be just for particular processes. So any open documents, take a copy of the RAM for the Microsoft Word process, etc. Now, because we are database professionals, we want to take a copy of the RAM open and attach to database processes. So I'll show you how to do that using Task Manager and create dump files and save those off to disk as well. A quick word here about the volatility of memory. So, why do we want to do RAM first? Because RAM is random access memory. RAM is overwritable, and when you turn your computer off, um, in a broad sense, the RAM is wiped. So when you turn it back on again, the contents of the RAM prior to the machine turning off aren't accessible. And for that reason, it's a good idea to capture the RAM while the machine is running. So a live capture. Okay, so that brings us to the end of the slide deck. I'm going to quickly show the ACPO guidelines, and we'll talk about some of the principles, and then we'll be on to the next video, which is actually doing the demonstration of first steps in the digital scene. So let's head off to here. There will be a link on the supplementary material for this video. This is the ACPO Good Practice Guide for Digital Evidence. It was written 11 years ago, and the consequent to that is this on the College of Policing. This is for the UK, extraction of materials from digital devices. It's called the APP, the Authorised Professional Practice. Sadly, it isn't available to the general public, and we have to be a member of the police force to get access to this, so I can't show the contents. For that reason, we're going to just refer to this document, and I won't read all of it out to you, but there's a few principles in the first third which I think are important. And it's worth noting that some of the follow-on links given in this document link to codes of practice that were never written and don't exist. So this was very much an unofficial guide written by the Deputy Assistant Commissioner for the Met Police at the time. So take it not as gospel, but as a guideline for what you should be doing. So let's have a look at section 2, which is a really interesting set of principles. Principle 1, no action taken by law enforcement agencies should change data which may subsequently be relied upon in court. This is exactly what we're talking about, that we need to make sure we have true and authentic copies of data. Where we need where we find it necessary to access original data, the person doing so must be competent, able to give evidence. That presumably goes without saying. Principle 3, an audit trail or other record of all processes should be created and preserved. An independent third party should be able to examine those processes and achieve the same result. Contemporaneous notes and video recording are ideal for these purposes. And principle 4, the person in charge of the investigation has overall responsibility for ensuring that these principles are adhered to. Okay, so there's some explanation of the principles going forward here, and then it gives you some guidance about what to actually do. So where practicable, proportionate and relevant, an image should be made of the device. So this is really good because we can take that image, examine it without destroying the original evidence. We talk about how we can make a physical or logical block image of the entire device or a logical file image. Now, ideally, we would do a block image of the whole device, but sometimes because of technological limitations, maybe we can't. So logical files with contemporaneous notes to try and to make sure that we capture that as authentically as possible. Sometimes we can't obtain an image. Maybe our data is stored, remotely, and this is a bit out of scope of what we're doing today because we're not talking about cloud database forensics, which is an undefined field at the moment. But it's worthwhile thinking about how we can get access to remote copies of that data, whether we need to download it first, and how we can authenticate that data. We need to demonstrate how evidence has been recovered and each process that we followed. And then a disclaimer about whether the application of these principles, whether they're complete, which they're not. And 2.2.9, application of 4 principles, forensic science regulators forthcoming codes of practice and conduct, and the Forensic 21 program. Forensic 21 program was disbanded in 2013. So very difficult to get any information about that. Again, use this as a guideline, not as gospel. And let's just scroll down a little bit. There's some more interesting principles that I wanted to take a read through as well before we end the video. So we have our plan and capture. Okay, proportionality. Database systems, well, in fact, computer systems as a whole, as I alluded to earlier, are enormous, and a target machine's hard drive might be terabytes large. Memory will certainly be gigabytes large, and a gigabyte is a huge amount of information. If you consider a gigabyte um, as perhaps the length of a film, a length of a short film, maybe you may think, oh, well, actually, it's not so much information. But if you consider a gigabyte in terms of documents and text files, that same gigabyte can store millions and millions and millions of documents. Okay, so it isn't really conceivable for us to dump an entire device and look through every byte or every kilobyte or every megabyte or every gigabyte of information. And sometimes we might prefer to take a more targeted approach. And this is what section 4.3 talks about. This is the same reason why we will be doing selective memory dumps of database processes rather than the whole memory dumps in our example demonstrator video. So that's the end of this video. Do take a look through this document and refer to the slides. And in the next video, we will be doing a demonstration of taking a live memory dump and a demonstration of taking a copy of files. Thank you very much.